The best one
Hey,
and the best.
you got something for you?
I would know.
Oh,
I
it's
don't
in
know.
the elevator, huh?
I don't see it anywhere.
For some reason, this becomes the hardest chapter. I don't know why. Personally, I think it's pretty straightforward. You just have to memorize a few things, and the rest of it kind of flows really nicely. So,
Hold on, I gotta get a sheet of paper. You gotta give me some time. Take some time. I gotta find a pencil.
Might not want to teach this one off the top.
Okay. I told her it would be the greatest thing.
No, I've been doing the whole class that way. So.
Oh, the talking animals.
Might as well write your own book now.
I think we're with LSD. I think we came out with LSD when I was on LSD.
Oh, yes, definitely. You all should go see Oz.
I've heard two different things of that. Good, bad.
It was a really good
It's
movie.
one of the two. So the trig relationships you need to know. You need to know that secant of x is equal to 1 over cosine of x, and vice versa. Cosine of x is equal to 1 over secant of x. So this is called reciprocal relationships, or identities. Cosecant of x is equal to 1 over sine of x.
Hold up.
Already?
This
Yep.
is stuff we should know.
This is stuff you should already know. Cotangent of x is equal to 1 over tangent of x. And then there's two others you need to know off the top of your head. Tangent of x is equal to sine of x over cosine of x. Why? Because tangent is equal to original unit circle. Tangent was y over x, y was sine, x was cosine. So tangent becomes sine over cosine. And cotangent, therefore, must be its reciprocal, so it would be cosine of x over sine of x. Pretty much what all of these are saying. You couldn't wait till
No.
Pretty much what all of these are saying is you can change almost all into sine and cosine. So that's going to be our trick. When in doubt, change everything into a sine or a cosine. All right, other identities you need to know. Simplistic ones, but ones I haven't talked about yet.
So cotangent is this cotangent. No, 1 over tangent is the same as cosine over sine.
1 over tangent is what?
1
Cosine
over
over sine,
tangent
yeah.
is the same as cosine over sine.
Yeah.
Okay.
Negative identities. These come from a picture. If this is your angle and it ends on a coordinate a comma b, and let's call this theta coming up. If we go backwards, that of course becomes negative theta. What does the coordinate do? If theta brings you to a comma b, negative theta is going to bring you to a negative b. From this picture, you can figure out sines and cosines of negative angles. For instance, if I do cosine of negative theta, that's exactly the same as, well, cosine of negative theta is a, let's put a and b on a unit circle. So cosine of negative theta is the same thing as a here, right?
Yeah.
If it's on a unit circle, but that's the same thing as a up there. So cosine of a negative angle is the same thing as cosine of the positive angle.
Oh.
Okay, ready?
Explain.
If
I'm
you
sorry,
take-
I was writing.
If these 2 points are on a unit circle, this radius is 1, then what happens is if you take cosine of a negative angle, negative theta, cosine is the first coordinate.
Yeah.
So if it's equal to a, well this one's also equal to a, and that's related to cosine of positive theta. So cosine of negative theta is the same thing as cosine of positive theta.
So is cosine of is sine of theta?
We're getting there. So what happens if I do sine of negative theta?
Stay negative.
Well,
It'll
sine
stay
of negative
negative.
theta is equal to
Negative.
negative b.
So it would be sine of
But b is equal to,
b
well, this b is equal to,
theta.
what kind of theta?
Positive.
Which one? Cosine of theta equals A. Sine of theta equals
B.
B. So I can replace B with sine of theta. So this becomes negative
I'm so confused.
sine of theta.
Okay.
I can write something
I got
down.
it.
A equals cosine of theta.
Yeah, you gotta write
B
it so down.
equals sine of theta. So I can take this B and replace it with theta. So you get negative sine of theta. So cosine of the negative angle doesn't do a darn thing. Sine of a negative angle changes its
Negative.
sign. The negative kind of
Yeah.
flows through if you want to think of it that way. So what about tangent of negative theta? Well, tangent of negative theta is the same thing as sine of negative theta over cosine of negative theta. What's sine of negative theta? Negative sine of theta. What's cosine of negative theta?
Positive.
Positive cosine of theta. So this becomes negative tan of theta. Negative identities. Either memorize it or figure out the picture.
Figure out the picture.
Figure
We'll
out
just
the picture. It's not
memorize
that
all of
hard.
that. So, do we need to know the sine negative theta over cosine negative theta?
Well, this tangent of negative theta is equal to negative tangent of theta.
Okay.
I used these two to come up with this identity.
I'm
I wasn't
gonna
going to do
write
it
this
with the
down.
coordinates.
Cosine
Pythagorean identities.
Can you slow down a little bit,
No.
please? Because you write really fast and you talk.
With a marker, and I can talk at the same time.
Yeah, and
And I
I
write
can't
big.
listen. I can't listen and write at the same time.
Big star next to this one, you use it all the time.
Even in the last chapter?
Well, this one you don't use too often for this chapter. You don't use the negative ones that often. We're going to use it maybe once or twice. This one we use every problem. And this one we probably use pretty much every other problem. So it gets pretty used up. Pythagorean identity comes from the unit circle. So on a unit circle, the equation is x squared plus y squared is equal to 1.
Oh, I remember this.
Yeah, you should. What does x represent in a unit circle according to
Cosine.
theta? So this would be cosine theta squared, and y is
Sine theta.
sine theta, and we're going to square it, and it's going to equal 1. Bad notation. Cosine theta with a bunch of parentheses around it and then squaring it takes too long to write. So what we're going to do is we're going to abbreviate it as sine squared theta. Instead of sine theta all squared, we're going to write it sine squared theta. Technically, it's illegal because you can't square a function. But this is pretty much saying take your answer of sine of theta and square it last. It's just a shorthand notation. So you get this identity. Sine squared plus cosine squared is equal to 1. And theta, of course, can be replaced with x, y, alpha, beta. It doesn't matter what the letter is.
The one that's
B.
over there, do we have to know
These,
all that? Do we have to know?
you need to know the beginning and the end. So you need to know the cosine of negative theta is equal to cosine theta, sine of negative theta is its opposite, and tangent of negative theta is its opposite. All right, if I take that identity and manipulate it a little bit, well, let's see. If I take sine squared theta plus cosine squared theta, and I know it's equal to 1, and I just choose, for the fun of it, to divide everybody by cosine squared theta. The only one I memorize out of these 3 that I'm going to come up with is the one in the box. The rest of them I derive. And to derive one of them, you just take everything and divide by cosine squared theta. Now, this is sine squared theta over cosine squared theta.
Tangent.
It eventually turns into tangent squared because you can write it as sine over cosine all
Square.
squared, and then sine over cosine is tangent squared, and abbreviation style is
Tangent squared.
tangent squared theta plus
That's going to just be
1 is equal to 1 over cosine squared.
that's
Secant
your
squared.
This is secant squared. So this gives you a second trigonometric identity. Tangent squared plus 1 is equal to secant squared. Or 1 plus tangent squared is equal to secant squared. Alright, we can come up with another one by taking the same identity and dividing everybody by sine squared. If I divide everybody by sine squared, you get the last of the trigonometric identities. Sine squared,
So
sine
this
squared.
is the last one. There's only 3 of them.
There's only 3 of them. But then out of each 3, there are 2 others.
That's cotangent.
Cotangent,
And
One.
cosecant.
1
1
plus cotangent
squared theta.
squared theta is equal to
Cosecant.
cosecant squared theta. And that gives us our third one. I highly suggest not memorizing these 2.
What?
Memorize this one. Sine squared plus cosine squared equals 1. If you need the other 2, divide by sine squared and divide by cosine squared. It's much easier. It doesn't take up so much brain space.
I do remember doing these.
Right. The problem with these is each one of them has 2 more associated with it. The first one would be cosine squared theta by itself is equal to
1 minus sine squared.
1 minus sine squared. And of course, the second one would be sine squared of theta
1 minus cosine.
is 1 minus cosine squared theta. And you could do that to each and every one of these. This one here, you can have secant squared minus tangent squared is equal to 1. You could have tangent squared is equal to secant squared minus 1. And the same thing for the cotangent cosecant one. You can rewrite them, and each one of them is 3 different ways. So basically, it's 9 identities in one,
Okay.
which is kind of scary. All right, so what other identities are there?
Hopefully no.
Oh, there's tons.
Oh.
This whole chapter is based on finding these identities. What's equal to what?
Is that why there's not many chapters in this section? Or not many
There's only
sections in
5
this
sections.
chapter?
There's 6 sections.
So, would you do the same exact thing for the other ones, like secant squared minus tangent squared equals 1?
Yeah, you can do that.
Okay.
That's what I was just saying.
Okay.
In this one, you can write cosecant squared minus 1 is equal to cotangent squared. That's a more popular version of it. Alright, so that's Pythagorean identities. Next up is probably the harder part. Verifying identities.
Why would you want to do that? Why would you want to do that?
You have to learn how to manipulate a trig. Trig is weird because you could have one answer and it looks perfectly fine and it's actually the correct answer, but it can get manipulated into a simpler form using these identities that I have up here. So to start off with, we're going to verify an identity. Number 1, never move pieces over the equal sign. It is not an equation. You cannot move something from the left to the right and vice versa. You're not trying to.
Did.
Yeah, man.
Yeah.
These are different. These are basic identities. When we're verifying an identity, you cannot move things from one side to the other.
Wait.
I'm not verifying over here. I'm showing you identities. These are
Showing
identities.
them why they are their identities.
These are derived identities.
So you're showing us why they are identities.
No. These are derived identities. I want to use them to verify identities. You'll see, it gets uglier.
I don't want it to.
Yeah, I know. So you can't move things over the equal sign. Number 2, usually, not all the time, change everything into sine and cosine. As much as you can in the beginning until you get used to what you're doing, just change everything into sine and cosine. So you're only dealing with 2 functions and not a ton of functions. 3, this is the hard part.
I'll just review the rest of these. Be creative.
Be creative? Why would you want to be creative?
Mix it all up.
Remember ever asking your teacher, why don't you just give us the answers and we'll find out how to get there? Right?
No, I don't ever.
You don't ever remember asking
I
for that?
never asked my teacher
I used to
that.
ask that. These things
Oh,
always
no wonder you're Sam's dad.
These things always have the answers attached to it. You're going to take the left-hand side, manipulate it, and the right-hand side is your answer, or vice versa. So the answer's there. You just have to
Figure it out.
figure it out, how to get there, logically, not being creative. And that's where this be creative comes in. The things that come into play: common denominators,
What class?
conjugates. Remember conjugates?
Oh,
I remember
yeah.
debating
Yeah, conjugates come into play a lot.
Somewhere over.
Conjugates again?
Those are the two big ones, conjugates and common denominators.
Or conjugates again?
Square
A
root of
plus B, A minus B.
Oh.
You change one sign in a binomial. Yeah, I don't care which one. So let's do a simple one.
Yes.
Very boring, but
What
it
do you
gets the
mean
idea
the
across.
answer? What do you mean the answer is the other side?
That's what I said. Here's a simple one.
That's what you said. I
know.
understand
Let me
that.
show you. You get to pick one side.
Oh, we know the answer. It's cosine of x.
This is an easy one. to
We know the
say,
answer is
right?
cosine of x. Now, you pick the side that's usually messier. You can't manipulate cosine of x until you know a ton of identities, and they're usually ugly for individual functions. So you try to pick the side that looks horrible. And what you do is you never move pieces to the other side, and you usually change things into sine and cosine. So this one's already a sine, so I write it as sine of x times, what can I change cotangent into?
Cosine of x over sine of x.
So this becomes cosine of x over sine of x. Since you're dealing with fractions, I highly suggest you write this sine x over 1. Just so you don't get confused and do weird things. Alright, you can put the equals here, and if you want, you can put the cosine of x. You're just dropping that one down. Keep your work on the left, keep your work on the right. You really shouldn't touch the right at all. Alright, what happens to the sine of x's?
A poof.
They cancel, and you get cosine of x is equal to
Cosine of x.
cosine of x, and you have verified the identity. That's all it is. That's everything there is to verifying an identity. So that means if you see this product as your answer, you can change it right away to cosine of x. It's a simpler form of the expression. Are they always that easy?
No.
No.
Of course not.
I wish.
I wish too.
Of course not.
Okay, how about something a little harder?
I'm good. I think so.
Sine of x over 1 minus cosine squared of x. And I want to make sure that this thing is equal to
You said a little harder.
cosecant of x.
This is a little harder. Oh,
Just-
this one's no.
What is that?
Sine of x over 1 minus cosine squared of x is equal to cosecant of x.
Oh yeah. This one's easy.
Alright. You see a cosine squared or a sine squared. What identity should you start with?
Pythagorean.
Pythagorean. The only one I know about Pythagorean is sine squared plus cosine squared is equal to 1.
1.
Alright.
This on the bottom is 1 minus cosine squared of x.
The same thing as sine of
A
x.
equals sine squared.
Sine squared. So I can manipulate this side into be sine x over sine squared x. And this side is that, and the right-hand side should be cosecant of x.
And then it would be you would cancel out one of the sine x's.
Cancel out one of the sine x's, you get 1 over sine of x. And we want to make sure that that's equal to this.
Yep.
And 1 over sine of x is,
1 over
and the other side is,
cosecant.
and we verified the identity. That's it. Pretty simple. So far. And then we run into the worst one. I need room.
That's not good.
Nope. Sometimes these take up an entire page. Your page. This is probably one of the worst types. But I'm going to give you some more techniques that you can use. Number 1, fraction is this. Second fraction is this. And my answer that I'm looking for is that.
Why are you so mean?
Not that bad.
Can you leave us to try to solve?
No.
No. Not yet. You can try. Go ahead.
Sam, you'll confuse yourself.
Okay.
Actually, no.
Which side looks worse?
That one.
I usually make my left-hand side look worse. I don't know why. It's just a habit of left-handed. I do
That's
that.
alright.
So the left-hand side is really bad. How many terms are on the left-hand side?
4. 2.
2. 1, 2. How many terms are on the right-hand side? 1. So one of your goals is to take those two things and shove them together. So if I'm going to shove them together, what do I need?
Shouldn't you make
Common
your tangent
denominator.
side cosine and sine first?
Well, this side is.
Your tangent side.
I'm not worried about that side. I'm worried about only one side. Don't worry about the other side.
Common denominator.
Get a common denominator. What's this first fraction missing?
Okay, 1 minus sine x.
1 minus sine x. So I'm going to multiply the bottom by it and also
The top.
the top. Oops. Don't forget all your nice parentheses. What's missing on the right-hand side?
Cosine x.
Cosine of x, top and bottom.
Uh-huh.
Then the fun. Now, since I have a common denominator, just write it. It is cosine of x times the quantity 1 minus sine of x. That's the common denominator. What about the top? What's 1 minus sine x times 1 minus sine x?
One minus
Sine squared.
negative 2 sine x squared.
I'll give you that much.
Wait.
1 minus sine x times 1 minus sine x
Plus sine x squared.
plus sine squared x.
I'm sorry, squared x.
It matters. All right, minus cosine x times cosine x.
K squared x.
Cosine squared x.
Oh, whoopsie.
Jeez. All right, now
It has been a long day, okay?
next thing. I know I need a tangent, and I know what's going to happen. Cosine's already in the bottom.
They're gonna at least cancel.
So what I want to go away is
That.
1
That's
minus
gonna
sine
be
of x.
Wouldn't
So-
that be cosine squared x?
Which one?
Oh wait, never mind.
Yeah.
So if I want the 1 minus sine x to go away, I have to take everything in the top and change it into... Okay, I don't want cosine to go away. I want 1 minus sine to go away. So I need everything in the top to change into...
1 minus sine x.
I need sines. I need sines up top. So the only thing that's not a sine,
Cosine.
so what is cosine squared in terms of sine?
1 minus sine x squared.
So this becomes 1 minus 2 sine of x plus sine squared of x minus parentheses 1 minus sine squared x all over cosine of x 1 minus sine of x. You're looking for manipulation inside of manipulation. And this is why this chapter is just really kind of cool in a way. All right, what happens to the ones?
They cancel.
Rather nicely. The negative sine squared x in here becomes
Plus
positive, and then you get 2 of them, right?
2 sine x squared.
So you get 2 sine squared x minus 2 sine of x all over
Whoa, okay.
a yawn,
Yep, it's been.
the denominator.
It's time for the data.
It hasn't even started.
Oh yes, it has.
Not for me.
Question.
Yep.
Where, that 2 came from the 2 sine x, right?
Well, you get the 1 minus 1, it goes away.
Yeah.
You get a positive sine squared here and a positive sine squared there. 2 sine squared. And then you have your minus 2 sine x.
Okay.
What can I do to the top?
You can get some like factors.
Factor out what?
Sine,
Two.
2 sine.
2 sine. So pick up 2 sine of x. Leave behind
Sine x minus 1.
sine x minus 1. And this is over cosine of x. And 1 minus sine of
Should
x.
we factor out a negative?
You could have. But if it ends up backwards, what happens if you have a minus b over a b minus a?
No.
What happens if you have a minus b divided by b minus a? What's its answer?
-1.
Negative 1. So if you cross those two out, since they're commuted over subtraction, you just have to change the sign. So we're going to cancel these out and add in a
Negative.
negative. That fixes
And then
everything.
Sine x over cosine x is tangent.
And your final answer is
Negative 2 tangent.
negative 2 tan x, which is
Oh, sorry.
what we start with.
Woo!
It's what we want.
This sucks.
That sucks.
But this is the manipulations you have to do. You've got to look at what you have, and you've got to look at where you need to go. And using that balance, you should be able to get through these problems. It's when you lose focus of the other side that you do little circles over here. You come down and you end up back where you started. So you have to make sure you're not doing that. You don't want to do cycles. You want to go in a direction towards the other side.
Stinks.
I always like this.
That's
How about... I'm not going to do that one. So that's my entire page. Take notes. Here's one. Example. Tan of A times tan of B over tan of A plus tan of B. And I want to see if this is equal to 1 over cotangent of A plus cotangent of B.
So is there ever going to be a possibility of where you try to trick us, because we know that you like to do that?
Oh, and screw up the other side?
No, and they don't equal each other.
No. They have. If it's a verifying identity, they have to.
But are you ever
I would
gonna
never
give,
not make them equal.
are you ever going to give us a problem where it's like, are these two equal?
Oh, that's possible, I guess. But I would never do it. These are hard enough as it is.
Okay. But they did that to us in calculus.
Did they?
Would they?
Horrible? No, because they would just use identities to prove other things. They don't really prove these things.
Cool.
Okay, so what side looks worse?
The left.
The left. This one's cool. You could either choose the left or you could choose the right, and what'll happen is you'll get the opposite side after some manipulation. But most people would go for the left. What would you do to the left to make it look, well, not better, it'll actually look worse?
Tangent over tan A plus tan B. Tangent A over tan A plus tan B.
Huh? Oh, you're trying to separate it. No, don't do that. That's not
Okay.
worth it.
Okay.
I'll give you a suggestion. Normally you would change everything into sines and cosines.
Shouldn't do that.
You shouldn't do
Because
that
it
because the
does
other
that.
side is just in terms of,
Cotangent.
Can you,
so just change this side all into,
That sucks.
can you change the
yeah, but I said we're going to pick this side. So I'm going to change everybody on this side into cotangent so it looks a little bit more like that side. So what's tan A in terms of cotangent?
Cotangent A.
1 over cotangent of A times 1 over cotangent of B over 1 over cotangent of A plus 1 over cotangent of B.
Really?
You could change everything into sines and cosines, and the same thing is going to generate out. It just, you have to write a lot more. A lot more. But it's easier if you can see the other side and you know what your goal is. Sometimes you can shortcut that
That
stuff.
looks awful.
It's not that bad.
You wouldn't do that to the part.
What, this?
Yeah.
This isn't bad. What kind of fraction is this?
Material.
Complex. How do you simplify complex fractions?
Multiply the
Multiply by the
denominator.
Reciprocal.
common denominator.
Oh, never mind.
You can't reciprocate because there's a
All
plus in here. So the only thing you can do is multiply top and bottom by the common denominator, which is
all that stuff.
Wow.
cotangent A and,
Cotangent B.
so cotangent A, cotangent B. Now these are multiplied together. So cotangent A times cotangent of B. This trick you have to get down pat because these show up all the time, complex fractions. Multiply everything by the common
So
denominator.
that basically, would the top basically be?
Wait, I think you said common denominator. Why are
The common
these-
denominator is
why-
cotangent A, cotangent
I
B.
have a question.
Oh, so, okay. But why are you multiplying the cotangent of A and
No.
cotangent B when it's addition?
But I'm multiplying it. If I did get a common denominator between these two, it would be those two factors. Watch what happens after I multiply. Are you going to stop yawning eventually?
Probably not. I'm really tired. So, could you basically combine 1 over cotangent A, cotangent B,
Mhm.
and then it would just be 1?
So when you multiply the
So
top,
did I just tell you what you were supposed to do?
yeah. When you multiply the top, it's cotangent A, cotangent B on the top and the bottom, so that becomes 1. Now you have to distribute it on the bottom, so when it hits the first one, what goes away?
I have no idea.
Cotangent.
The cotangent A goes away and you're left with cotangent of B, plus when it hits the second one, what goes away?
Cotangent B.
The B's go away and you're left with,
Cotangent A.
which is exactly the same as
That.
because addition is commutative. You can switch over addition.
Wait, what?
Booted.
Oh.
When these two run into these two, this is multiplied all together. So the top and the bottom would be exactly the same. So that would be 1. When you distribute this one to the first fraction, cotangent of A is in the bottom. This cotangent of A is in the top. They cancel and you're left with the other factor times 1.
Can you let him finish?
waiting for your definition.
Oh. And then when you multiply these two times the second fraction, the cotangent of b's are going to cancel, and you're left with cotangent of a times 1, which is just plain old cotangent of a.
What I was trying to ask earlier is why are the cotangent A and B multiplying each other when the denominators are addition?
Okay, where are you? Here, right?
Yeah, they're addition there.
How are you going to add those two together?
You do.
How are you going to add these two together? You need to get a common denominator. The common denominator is 6. You multiply them together.
Yeah.
You don't always have to multiply together.
No, but it's the quickest way to get a common denominator. I mean, if you have 1 over x plus 1 over y, the common denominator is xy. What's that?
What if you did the right side?
What if you did the right side? This would turn into 1 over tan A, 1 over tan B, multiply times tan A, tan B, and you end up with this.
You.
Wait.
Which part?
All of it.
How did I come up with these two?
No, I want that.
Okay. When you multiply these two, when you multiply fractions, this actually comes together as 1 over cotan A, cotan B. If you multiply this times this, these two are in the top, these two are in the bottom, that becomes 1. When you multiply these two factors times this one, this is in the bottom, this is in the top. So the cotangent of A's are going to cancel. Right. So you're left with 1 times cotangent B. Cotangent B.
Got it.
Wait, what?
So when this one gets hit, the cotangent B's are going to cancel, and you're left with cotangent of A times 1, which is cotangent of
Wait, why didn't the top do that?
A.
Can you work it out?
1 cotangent of A times 1 over cotangent of B is equal to 1 over cotangent A cotangent B. These are multiplied together, not added.
Okay.
Okay.
Well,
You're
that's
still
what-
got that
that's
classy
what-
look.
That's why I was asking about the
So
addition.
1 over cotangent A times cotangent B times cotangent A cotangent B over 1.
If you want, yeah, you can put these over 1.
That's a lot.
Okay, you do that.
Yeah.
to just designate which one's on top and which one's on the bottom.
And then when you do the bottom part, you do cotangent A
Cotangent B
Cotangent B.
1 times this one.
times that.
So the cotangent A's are going to
Cancel
Disappear.
out.
Disappear.
They cancel out, so it'd be cotangent B over 1.
which is cotangent B. Pulling teeth.
So why can't you add the bottom together?
Is it time to go?
Why can't you add the bottom?
It
together?
is.
What?
Like what you did up there with the impact. Why can't you do that to the bottom one?
You can, but then you'd have to multiply this one top and bottom by cotangent of B, and this one top and bottom by cotangent of A, and it's not worth it because you're going to multiply by those two to get rid of the fractions to begin with. It's a nice trick with complex fractions.
So,
Oh dear God.
so would this be right the way I worked it out like that? Or is that wrong?
Oh, that's wrong.
Wrong.
Yeah, big time wrong. Well, no, you can't cancel out through addition. You made that addition. If it was multiplication, you'd be perfectly fine. You can't cancel out through addition. Don't make up math rules. Math rules cannot be broken, ever.
You break them all the time.
You break them all the time. All right, study for the test.
This?
Yeah.
Instead of 5-1. Ooh, get rid of this picture.
Gotcha.
Nap time.
Nap time. Kindergarten.
I still had nap time in 1st grade.
Did you?
Yep.
I don't even think I had nap time in kindergarten.
So is this 5-1 still?
5-1, continue just for a little bit. There's other types I want to nail down. One from my notes, and then I'll take the rest of them out of the book. I'll see how they work.
Is this where we picked off yesterday? Or it equals on the other side we had to build?
Yeah, okay? You have to kind of pick a side and force it to look like the other.
How can you tell which one would be easier to do?
You don't know sometimes. Like this one, doesn't matter. This one doesn't matter.
That was funny.
This is actually an important identity to be able to switch one into the other. Fractions generally are nicer if you can just have one piece in the denominator rather than two. So if we can do this switch, it's really nice later on. But before we can do that, we have to prove that these things are actually truly equal to each other.
Right.
So technically, I mean, I forgot to say this yesterday, technically what you're supposed to do is say, are they equal? And then you go about proving that they actually are. It really doesn't matter which side you choose. The technique on this one's a little weird compared to the other ones. The other ones were complex fraction reduction and combining fractions with a common denominator. This one, you have to do what's called an add-in. So what I'm going to do is I'm going to play with the right-hand side. It doesn't matter if you play with the right or left, but I'm going to choose the right-hand side. Gives me a little more room on that side too. And here's the goal. The top over here has a sine, and I want to force it to become a cosine. The bottom over here has a cosine, and I want to force it to become a sine. And you can't just take the fraction and flip it. That's just illegal. So here's the trick I'm going to play.
Are they gonna arrest me?
Yeah.
Are they going to arrest me? I'm going to take the top and the bottom and multiply it by something. And I'm going to multiply it by something that's kind of special. This is really close to 1 minus sine squared x, right? If you think about it, it looks kind of like 1 minus sine squared x. I'm going to kind of lean that way. And I know that 1 minus sine squared x is equal to cosine. But of course, this one is just cosine by itself, and that would be cosine squared.
All right.
So what I'm going to multiply by is its conjugate. What is the conjugate of 1 minus sine of x?
1 plus.
1 plus sine of x. I could also say, well, I want a 1 plus sine of x in the denominator, so I can just shove it in the denominator over here. But if I put it in the bottom, I have to put it in the top. So either way of thinking works perfectly fine. And you still get this 1 plus sine of x top and bottom.
All right.
So if you look at the other side, it has this 1 plus sine of x, and if you multiply top and bottom over here, at least over on the right-hand side, this 1 plus sine of x is now in the bottom.
Oh,
I'm interested in being in the bottom. All right, if I multiply out the top, what do I get?
1 minus sine squared x.
1 minus sine squared x. Those two middle terms cancel because they're conjugates. And the bottom becomes
Cosine x
cosine of x
plus.
times. Oh, no, keep them separate.
Okay, times 1 plus.
Because I really want that 1 plus sine of x to be by itself.
Okay, so top.
So cosine of x times 1 plus sine of x. That way at least I have the 1 plus sine of x correct in the bottom. Alright, what can I do with 1 minus sine squared of x?
Here's a question.
I have no idea.
Why'd you do 1 plus sine of x?
It was in the bottom here, and it wasn't over here, so I'm forcing it in the bottom. But if I put it in the bottom, I have to put it in the... And multiplying the top by it seemed to actually work rather nicely.
Uh-huh.
So what's 1 minus sine squared x equal to?
Cosine of x, I thought.
Cosine, don't forget the square, x, over cosine of x times 1 plus sine of x.
Well, what is that? S? Oh, cancel.
Yeah, the cosines will cancel.
One of the
One of them
cosines will cancel, and you're left with cosine of x over
1 plus
1 plus sine of x, which is
That's cool.
What you had to begin?
the other side. So we just verified that we can use this identity. If I see cosine of x over 1 plus sine of x, I can always replace it with 1 minus sine of x over cosine of x. It's kind of neat. Let me steal some out of the book. How bad did they get in here?
I don't remember.
Probably not as bad as you.
I'll just write them on the board, don't worry. Boring,
page? What page?
boring. It's 594, but it doesn't matter. I'll write them on the board anyways.
Oh, no. Might as well use your paperwork over there.
This one, 32. Cosine of x over 1 minus sine of x plus 1 minus sine of x over cosine of x is equal to 2 secant of x. I feel like I've done this one.
You did a 2 tan. You did a 2 tan one.
So this is really similar. Let's see if you can remember without looking at your notes.
Well, I don't have my notes.
Good.
You have?
Without looking at your notes.
Oh, no.
No, you're cheating.
This one's different.
I don't care. You're cheating. Stop looking at your notes.
Different.
You don't get to answer them.
I thought it's different.
It's a little different, not too much
Somebody
different.
go.
So the goal here is
We're not rusty.
ugly mess on the left,
Nice.
one piece on the right, two pieces on the left. So I want to take the left and make it,
Condense. You wanna-
bring it together as one piece. All right.
Great.
To bring it together as one piece, what do you need? Common denominator.
CD.
What's this one missing?
Cosine.
Cosine of x. Make sure you put parentheses here. And of course, another cosine of x. What's this side missing?
1 minus
One
sine.
side.
1 minus sine of x. Top and bottom. And don't forget the parentheses there.
Alright.
Try to get ahead of me.
Try.
Try.
Hold up, I gotta write the problem down.
I'll give you a hint.
Is he?
The denominator is cosine of x, 1 minus sine of x. Give me the numerator
Alright.
without any parentheses.
Of
Of the top.
oh,
The combined top.
Alright.
cosine squared.
Hold on. You gotta give me some time
Let
to
them write and scribble all over their papers. That's the easy part anyways. Oh, plus, yeah, this is the second easy part. Awesome, plus.
Oh, it's gonna be 2 minus.
1,
2 minus both.
1
2 minus.
1, that's another easy part.
minus
Minus
2 sine x
2 sine x
That's
plus
where
sine
it is.
squared x.
plus sine squared x.
Oh,
This is slightly different than the
These-
other one.
I
This
got
one
it
actually
wrong.
works out quicker.
Wait, I got it wrong.
When you multiply these two binomials, make sure you FOIL them out. Don't just square the first one and square the second one. You gotta FOIL. Alright, now here's the cool part. Whenever you see a sine squared and a cosine together, make sure they're either both positive or both negative, and you can do the nice little Pythagorean identity. What is cosine squared plus sine squared?
1.
1. So basically they come together to give you this big nice 1 and they just disappear. Because
The whole
they
time?
equal 1. Yeah, cosine squared plus sine squared is 1 automatically.
Alright.
Is that nice Pythagorean identity? So here we have a 1 plus this other 1.
2.
So you're going to get 2 minus 2 sine of x, all in the top. And in the bottom, cosine of x, 1 minus sine of x.
And then the 2 can be taken out. So like
Factor out the
factor
2.
Yeah.
So if you factor out the 2, you're left with
2 times 1 minus sine of x.
1 minus sine of x. And over cosine of x and 1 minus sine of x.
Alright.
Oh,
And
this
then
is
you
much
can-
nicer than the other one.
Then you can do you want to cancel out the sign?
Please do.
You have to cancel that.
Not just the sign.
The
1
1
minus
minus
sine.
that.
Yeah, take out the whole thing, and you're left with 2 over
Cosine of x.
cosine of x, better known as,
2 secant.
which is the other side.
That's not a lot of words.
Jeez.
That was much
Christ.
nicer than the other days.
Yeah.
We had to do a lot of others fooling around. Let's see if I can find another ugly one. Ooh, 36. Ooh, got it for
I know, I ain't got it right.
80.
You took up like a half my page here.
Yeah,
Took up my whole page.
I'll write a little smaller. 36.
Crazy. So call me maybe.
Cosecant of x minus secant of x over cosecant plus secant of x. And we want to prove that this is equal to
Didn't we do this one yesterday?
cotangent of x minus 1.
I don't think so.
Yes, it's minus 1.
Minus
Yeah,
1
we did.
over cotangent of x
Plus 1.
plus 1.
Cheese and rice.
Cheese and rice.
Yeah, they all start looking really similar. Alright, you have a choice. Left or right?
You
Oh,
wanna do-
left.
Let's do
Left? Okay.
Aw.
If we do the left, what technique are you going to use?
1 no.
Well, we've been doing.
You're gonna force one
Yeah.
over.
I haven't actually done what we were supposed to be doing yet.
Oh.
What you're supposed to do when it gets this ugly is, when in doubt, change everything into
Sine
Sine.
and cosine.
sines and cosines. So cosecant is
1 over.
1 over
Sine.
sine of x minus
1 over
Whenever
cosine
cosine
of x.
1 over cosine of x all over 1 over sine of x plus 1 over cosine of x. Alright? Okay. What's this thing called?
That's
Complex fraction. And there's only one technique you need for a complex fraction. Multiply everything by the common denominator.
CD.
So what's the LCD?
Huh?
What's the common denominator?
LCD?
Lowest common divisor.
Oh.
Sin x times cosine.
So sine x times cosine x, and you're going to multiply it top
And bottom.
and bottom. Chelsea, put a 1 under it
If you have to.
if you have to. Sine of x, cosine of x. And I'm going to multiply it through. Basically, everybody's going to get hit by sine and cosine. So when the first fraction gets hit by sine and cosine, what are you left with?
Cosine x minus
Cosine of x minus
sine of x
sine of x.
over cosine x plus.
Sine x.
Didn't exactly do what I wanted it to do.
That's horrible.
It got me, I guess.
But you
close.
got it into sine and cosine, so that's good.
Well, yeah, I got it down to at least a nice fraction, but
now
I
you
need
to
it to
get
be
into
cotangent.
You can get rid of. I can't.
So,
Can't you take like
You can't flip.
cosine
Can't
x,
flip.
cosine x over cosine plus sine x minus sine x over cosine plus sine x?
Huh?
Yeah.
like,
You lost me on that
Are we
one.
talking about
It's
pencil
not
now?
Like the denominator and then cosine x over that minus sine x.
But what are you doing exactly?
Oh,
Cheating?
you're part of.
Oh, you're saying take the first one, put it over these two. Take the second one, put it over the.
No.
Don't do
Okay.
that. Because then you're separating it into 2 separate terms, and that one is just
One.
1. You want to keep it as 1 term.
can we multiply them again by sine and cosine to make them squared?
Sure, but that's no fun. It'll only bring you back to cosine squared and sine squared. No poofs in this one.
Well, no, I mean, you can make the bottom into a 1.
I've seen people on the test go, these are equal. Or write this down underneath this one and say, oh, they're equal. You know, the magical, it happened in my head. It's like,
Oh, it is.
okay, now think for a second.
did this.
If you went on this side and you change things into sines and cosines, you're not supposed to write it, but at least you can look at it and see what they are. What is cotangent equal to?
Cosine over sine.
Cosine over sine, right? So if I take this cosine by himself and divide it by sine, he becomes
Cotangent.
cotangent. But if I divide him by sine, I have to divide
That by sine.
him by sine, and if I
Makes
divide
it
him by
one.
sine, it becomes.
1.
So I should take everybody here and divide by.
Sine
Sine.
over sine.
So divide everybody by sine of x. Top and bottom. Sometimes the other side gives you hints on what you need to do. So, cosine divided by sine, that becomes cotangent of x. Sine divided by sine is 1. Cosine divided by sine is another cotangent of x.
Plus
And sine divided by sine, of course, is plus 1. Done.
One and done. It happened in my head.
I don't
Just
know
like
why
that.
you do that.
Because I need a cotangent, and cotangent is equal to cosine over sine. So if I took this cosine and divided it by sine, I get my cotangent that I want. The problem is, if I divide him by sine, I could divide
But
everybody
I
by
thought you
sine.
couldn't separate it, because if there's a plus in it.
I didn't separate. I distributed. It's the same thing as multiplying by sine and cosine up here. I'm multiplying by 1 over sine. So it becomes cosine over sine, sine over sine, cosine over sine, sine over sine.
I'm getting really tired of cosine and sine.
Yes, you'll be sick of it by the end of chapter
Got a
6,
headache.
I just
which is the
really
rest of the
good.
book.
Yes.
You're going to learn this stuff for the rest of the book.
Rest of your life.
Well, that too.
What, really? Cool.
Yeah.
That's really not.
Nick's going to have a computer do all his work for him.
Damn darn right. I ain't invented for no reason. Invented for no reason. Use
Alright.
your resources.
What looks bad?
All of them, me.
Yeah.
And I'm still trying to figure out what the heck y'all doing anyway.
Ooh.
Let's do it.
Which one?
The one that you said Utu.
Ooh.
Some bad board.
Well, I'm not going to do it. 43 and 44 just look horrendously long and boring. How about
Organ board.
50. Oops. 50. New screen.
That's it.
The more you do of these, the better you actually get, which is kind of scary. This is cosine squared t
Yeah.
plus 4 cosine of t plus 4 over cosine of t plus 2 is equal to 2 secant of t plus 1 over secant of t.
Well, I know that what you can start out with is
I'm just trying.
you
Let
went back.
him write it down first.
Yeah, I know, right?
Definitely factor. That comes into play.
Oh, yeah, so can I just tell you
You can tell me eventually.
right now?
Okay, now we'll be good.
Would it be cosine t plus 2 squared?
All squared, yeah. This side factors of 4 that add up to 4 are 2 and 2. So you're going to get cosine of t plus 2, all squared, over cosine of t plus 2.
Wait, what?
You can factor the top.
Cost.
That's the same thing as factoring x squared plus 4x plus 4.
Oh,
It factors into x plus 2 all squared.
Uh,
Or in this case, x represents cosine of t.
So what if one of the cosines of t?
So this is where it gets a little strange. You get down to cosine of t plus 2 is equal to that side.
So how do you do that?
That's the problem.
Oh, wait, a secant over a secant equals 1 over cosine times cosine over 1, right?
Huh?
How do you spin this out for one?
Okay,
Okay, so
I can't touch that side. I know I need to
you
change it
can if
into a
you want
secant.
to.
I can if I want to.
Okay.
What could I do to make this one look more like him?
Change the secant over
Change cosine into
secant.
secant. So this becomes 1 over secant of t
where is this coming from?
plus 2. So you have to stay on the side.
But then how?
You know what your goal is. Your goal is secant. So you stay on the side, you change your cosine into this. Now you look at it. How many pieces are there? 2. How many pieces are there?
Oh, so you gotta get the common denominator. And that's
Common
gonna be
denominator is
secant.
secant of t. So you're going to take, oops,
So it's gonna be
let me just write it. Put it over 1, multiply it by secant t and secant t. So when you do that, the common denominator is
secant
secant of t. And you get 1 plus
2,
2 secant of t, which is
the same thing.
the same thing. But I've seen people get here and go, oh my god, and they give up.
No, I knew to get to at least that
Get
next
the
one there.
next
And then I
Yeah, once you get to there, it's like, oh, 2 pieces, 1 piece, gotta combine them. You have
Right there.
it's something you have to look at.
So you don't multiply the other ones over
This
secant
sucks.
t?
Over here?
Secant, yeah. No.
Oh, you're
Right,
getting a common denominator. This one already has a secant in the
Oh.
bottom, so you're forcing a secant in the bottom here, but you have to do the same thing to the top. All right, last ugly one I can find.
Why does it
Number
have to be
43.
ugly?
58 or
40.
60.
Mm.
I don't like that one.
Oh, jeez Louise.
And then your street papers.
Is it, what were you doing, 60?
60. I'm trying to get our test in by next Thursday.
Good.
I'm joking. No, I'm not. 60.
Sadly.
What is it, before spring break? Is that
Maybe
why?
a quiz or something like that. A paper quiz.
We haven't had quizzes lately, have we?
Yeah, that's what I'm building it up.
I gotta figure it out. So. Mm.
I already don't like
This is
it.
gay.
Oh, it's gonna eventually, isn't it eventually gonna become like,
Common denominator, right?
Yeah,
Can we just say
It's
that?
gonna be what?
is it gonna eventually become cosine squared?
Eventually, you're gonna get a bunch of sine squares and cosine squares out of this. I'll give you that.
find the common denominator first, or would you?
Yes. I would definitely go for the common denominator first, because you need, out of these 2 pieces, you do definitely need 1 piece. So that should be your first step.
Is it we sine
So-
x and cosine x?
What's missing on this side?
Cosine.
So you put cosine x top and bottom. Make sure you distribute it through. This side's missing. Sine of x. Make sure you put it top and bottom and distribute it through. This one I highly suggest you get rid of all the parentheses just to begin with, because otherwise it would just be ugh.
So we're doing the bottom first?
So the bottom, of course, is just plain old sine of x, cosine of x.
Alright.
Which would be perfect because that's actually equal to secant cosecant. If you put a 1 on top. So let's see what happens at the top.
Nothing.
Cosine times sine, cosine of x, sine of x. Cosine times cosine,
It's cosine squared.
cosine squared of x, minus,
I'm still trying to,
One.
no,
minus,
Minus
Sine
cosine.
squared of x.
sine
Yeah.
squared of
Cosine,
x.
no, it would be,
I'll put sine squared there, but,
no, because it's not, because it's going to be a positive sine
oh,
squared.
because you have to go negative times a,
Negative.
So
which
it's
is
gonna
a
be
positive,
I just said
So then it's going to be minus cosine x sine x.
minus cosine of x, sine of x. You must put your sine of x on the other side.
Why?
Actually, no, it doesn't matter. Why'd you do your distribution backwards?
From the cosines of x and the cosine x sine x cancel.
These two become,
Can we do the cancel part?
yeah,
One.
these two become 1. These two
Cancel.
cancel rather nicely, and you get exactly what I said, which is 1 over
Sine x.
sine x cosine of x. And you can separate these to be 1 over sine of x times 1 over cosine of x.
Which
One of
is,
those neat little properties of multiplication.
is that right?
Which is exactly that, because 1 over sine is
Secant.
This one's actually cosine.
cosecant
That's what I said.
times 1 over cosine, which is
Secant.
secant. So this one actually, it started off looking horrible, but once you started working it, it was actually simplistic. So don't let them
You wouldn't ask 43, would you?
scare you just because they look horrible.
Yeah.
Sometimes they turn out rather
You wouldn't
nice.
ask 43 or 44, would you?
43 or 44, not on the test. That would probably take you a little bit of time. But they're not hard. No, that wouldn't be hard at all. You change it into sines over cosines, you create a complex fraction, and when you multiply through by the common denominator, you get the other side.